Today we're doing 10-3 arcs and chords. If you want to make your foldable the way that it was intended, then you will take a pair of scissors and cut across these two dashed lines here so that each flap opens up accordingly. And we are actually going to go in that order, meaning I'm going to read this first theorem here. In a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Here's what that looks like. So we're going to do numbers 1 and 2 first. Since it tells us that this arc is 127 and this arc is 127, we know that this must be congruent to this. Okay. So looking at our example here, AB is 5x and CD is 3x plus 6. Well, if they are congruent, they must be equal to one another. So to solve for x, I'm going to subtract 3x. And divide by 2. So x equals 3. Now again, we haven't answered the question yet because we need to plug it back in for A, B, and C, D. So 5 times 3 is 15. And then 3 times 3 is 9 plus 6 is also 15. So they both equal 15, which checks out because they're supposed to be equal. Okay. All right, so same idea on number 2 here. This is 80 and this is 80, which means that this is equal to this. So 12x minus 2 equals 34. Add 2 and divide. X is equal to 3. And we're done there because it just said find the value of x. All right, let's go look at our next theorem. So our second theorem says in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. Bisects meaning cut in half. So if you don't remember that, maybe we put that there. Okay. So what does that look like in an example? Given that chord BC is 15 centimeters from the center, that's wrong, hold on, is 15 centimeters from the center. So that means actually that this is 15. And in that the circle has a radius of 25. So remember, radius is middle to outside edge. Find BC and DE. Okay. I'm actually going to find DE first because that's the easier one. So think about this. If from the center to the edge is 25, I know that this center to the edge must also be 25. So 15 plus what is 25? Well, that's 10. So DE must equal 10. Easy one done. The other one is just slightly harder because we have a right triangle. We know two sides and we want to find the third side. So we're going to do a squared plus b squared equals c squared. We do know c because it's across from the hypotenuse. Or sorry, the hypotenuse is across from the right angle. So b squared equals 25 squared minus 15 squared. B squared equals 400. So b equals 20. So that means from B to D is 20, but we actually want to find BC. So we want to find all the way across. It just doubles. 20 plus 20. BC is 40. Okay. All right, looking at our next one, we have a right triangle that is a 30, 60, 90. So remember our rules here. Hypotenuse is always 2 times the short leg. In this example, the hypotenuse is 6. So 2 times what gives me 6? Well, that is 3 is the short leg. The short leg on this triangle is CD. So we have found one of the things that it asked us to. Okay. Remember, long leg equals short leg times square root of 3. We just found that the short leg is 3. So the long leg is 3 square root of 3. Well, the long leg of this triangle is AD. And the last, it says, find the measure of the arc AB. So if we look, if this is 60 degrees, this is also 60 degrees. And since this bisects it, this is also another 60 degrees. And 60 plus 60 is 120 degrees. All right, and the last theorem. In a circle or congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So what does that mean? In this example, FG is 3, GA is 5, and AH is 4. We want to find PJ and LA. Well, since this bisects, if this is 4, this is also 4. So LA must be 8. 4 plus 4 is 8. Also, since these are the same, PJ must also be 8. Simple problem. All right, in this example, it says FG is 3x minus 4, and HJ is 14. Just like the other picture, this side is congruent to this side. So we set them equal to one another to solve. So adding and dividing. (18 divided by 3 is 6. X equals 6. And this concludes arcs and chords.